Hello and welcome to our workbook number 2. We're going to do some ISIS troubleshooting. So we're going to carry on from where we left off with workbook 1, where we've already configured our ISIS. We've confirmed we have our adjacencies up. Okay, so what we have here is our first task, where we have obviously our devices configured. But we did notice briefly in the last video that the iOS XE routers, especially CE2, CE4, they're not receiving any routes at all. So basically what's happening is that we are getting routes, but this device and this device are not. So these are unable to ping each other because they haven't got the routes in their routing tables. So with this task, we need to find out a way to fix this so we can actually get the routes into our iOS XE devices and we have full reachability going along. Okay, so we have some troubleshooting commands that we can try here, and I've put a little note on there as soon as it opens up. Basically, we're going to run some troubleshooting commands only on 3 routers, surprisingly, one iOS XR router and 2 iOS XEs, the 2 in question. And as I've stated here, they should be enough to get to the stem of the problem, but of course feel free if you want to run these commands on, or any other commands that you can think of actually. I mean, you're not going to break anything on any of the other devices as well. But just by doing these 3 will be enough to get to the stem of what the actual problem is. Okay, so we're going to run them in just a moment, and we have a couple of questions here. Again, and we'll answer these as we go along. So let's have a look and do our show commands first and see what's going on with this. Let's bring up my command. So we're going to do our show CLNS neighbors on iOS XE, show IP route, and show the database as well. See what we can find in that. And we're going to basically do the exact same thing, but ISIS neighbors on the iOS XR device. Okay. Do I need that? No, I don't. That's just showing me some Dockers that are running. Yeah, close that. Yeah, slightly different format than before because I'm going through one of my servers. So, but anyway, that's by the by. Okay, so let's have a look on CE2. So let's do a show CLNS neighbors, and what do we see? Okay, so we have our level 1 neighborship with CE1, sorry, CE2. So that's exactly, sorry, CE1, yeah, CE1, I'm on CE2. Yeah, well, we have our level 1 adjacency, so that's fine. Let's do a show IP route ISIS and see what we can see there. Okay, so all we can see is the routes that are in the same area, the 490002 area. So all we can see is the loopback of CE1 and the loopback of PE1. We're not seeing anything further along the chain. Okay, so that's fine. Let's have a look at the database. Show ISIS database. Now, if you do a question mark, you can decide if you want to see the level 1 database, the level 2 database. Let's try level 2. And there's nothing there because we originally set this up as a level 1 only. So let's do level 1. All right, okay, so we can see our neighborships are there. You know what LSPs we're receiving from the different devices all across, are being propagated through. So we can see the ones from PE1 that are being propagated through to CE1 to CE2. Okay, so we're not receiving anything other than level 1 routes. Let's have a look on CE1. So CE1, as we're aware, is one that connects directly to the provider edge. So let's have a look, see what we can find on that. So let's do a show CLNS neighbors. All right, okay, so we have 2 neighborships here. So we have a neighborship with CE2 that we can see, and we have a neighborship with PE1. Unsure now why that's actually come up as the net ID rather than the host name. Anyway, that's neither here nor there. As we can see, they are both, again, level 1 neighborships. Let's have a look at the routes. So, IP route, ISIS. Again, we're seeing exactly the same as we did before. We're seeing the loopbacks of the two directly connected neighbors. Okay, let's have a look at the provider edge, PE1. So let's log into this. One thing of note, while I've put down on here that the password, username and password is Dicky, because that's what people call me Dicky, but that's because that's what I set up when I initially configured the actual device. And I only found this out the other day, that the root password and the root username is not actually shown in the configs. So even though the configs are there for you to download, and the same for the last workbook, you will come with the iOS XR devices where it'll ask you to input your root username and password. Create whatever you want, it makes no difference whatsoever. All that means is that as soon as you've created your root username and passwords, the rest of the config will automatically be applied. Okay, so let's do a show ISIS neighbor on here. Okay, so we see we have a level 1 neighborship with CE1 and a level 2 neighborship with PE22, so we know that's in a different area, so that's fine. Let's have a look at our routes. Show route ISIS. Okay, and we can see that we're learning all the routes. That's really good. That's brilliant stuff, but we won't be able to ping the loopback of CE4. Let's double check that. Just double show IP interface brief. Okay, so that's 444. Okay, even though we have it here, as you can see, it's a level 2 route that we've learned from PE22, and let's try and ping that. Ping 4.4.4.4, and let's source that from loopback 0, and we're not getting anything. Again, we go on CE4, show IP route ISIS. It's not got any routes in its table other than its directly connected neighbor. Okay, so that's fine. So let's have a look at show ISIS database. And now we can see we have two different databases, one for the level 1 adjacencies at the top here, and we have one for our level 2 adjacencies here. All right, that's fantastic. Let's have a little jump on. So we've done the root, the neighbors, and our database. On CE4, we've done the root. Let's have a look at show ISIS database. Again, all we can see is the connectivity between, or the LSPs we're receiving from PE4. So what's happening here is while we have connectivity, which is, fantastic. So what we can see here is that the iOS XR devices, the layer 2 devices here and here, they're receiving all the routes, because by default we know that the level 1 routes will automatically be propagated into level 2, and of course the level 2 devices are moving them along. So what's happening here is that these routes here are automatically being propagated from level 1 into level 2. Okay, that's fine. And then they're being sent via level 2, level 2, level 2, all the way across. But the problem is that the level 2 routes are not by default propagated back into level 1. So which is why that this device is not receiving any of the level 2 routes, and consequently the whole journey this way, these are not receiving any of the actual routes either. Okay, so there's a couple of ways that we can work around that to see if we can fix this. One is to inject a default route. So we can do a default route on, let's say, the PE. So if we go on PE1 and we was to go into the address family, so PE1, and let's go conf T, and let's go router ISIS1, and let's go address family IPv4 unicast, and we can do a default information originate, and then that will propagate the route it will propagate a default route into its neighbors. But the problem with that is that will also propagate a default route to our external neighbors as well. So it won't just propagate that in through level 1 neighborships, it will propagate that through to level 2 neighborships as well. So that's not something that we actually want to do. So the ask here is, let's go back to the ask, we just need to get everything pingable, so the iOS XR devices can actually communicate with each other. So regarding our questions, why are the routes not being shared? Well, we know this. iOS XR and XE, to an extent, they don't automatically by default propagate routes from level 2 into level 1. So again, if the default configurations were used, so if we didn't specify any levels, so if we didn't specify that, for argument's sake, CE1, CE2, PE4, etc. were level 1s or level 2 routers, and we left them as default, then what would happen then, by default, is that they would create level 1 and level 2 adjacencies. Now, again, we've seen this sort of thing in the past, but that's not something we want to do. We don't want our devices, our CE1, our CE2, and our PE4 and our C4, we don't want them having two neighborships with each other. They don't need to have a level 2 neighborship unless they're breaking out. The whole idea of the level 2 is you have a level 2 neighborship, so it can form a neighborship with another device in a different area, and then creates the discontinuous backbone. So that's not something we want. So we could do that, of course, but that's not what we're going to do. We're not going to sit there and create additional adjacencies just to get some routes in there. But yes, it would actually overcome it, but that's not what we're going to do. So again, another question, on what devices do we need to make changes to complete task 1? Well, we need to make the changes on the iOS XR devices, the PEs, the ones that are not, transmitting the data, propagating the information from level 2 into level 1. And again, what sort of changes do we need to make without changing the interface assignment? So with these devices, with iOS XR, we will create a root policy. So we'll create a root policy. We'll basically, a simple one, basically saying pass. And then what we'll do, we'll go into the address family, and we will apply that root policy in the end of a propagation statement. So whereas iOS XE uses redistribution, so you'd redistribute on an iOS XE device. So if you had iOS XE that was running level 2, you wanted to get the routes into level 1, then you'd redistribute. You use the same thing. You'd use the prefix list and then the route policy or policy map. However, with iOS XR, it's called the propagate for that. So what we're going to do, we're going to propagate that. So I've got the solutions here. If you want to look at them later at your leisure, but basically, again, what we do on our P1, we're going to create our root policy, and then we're just going to stick the root policy into the address family and do our propagate. Now, the thing is, it's not going to affect, if we put it on P1, it's not going to affect PE2, because the idea is we're going to propagate from level 2 into level 1. There's no neighborship between PE1 and PE22 that's on level 1. They're level 2 only, so we'll have no bearing on that at all. The same as when we do it on PE4, it's going to have no bearing with its neighborship on PE22. It will only affect the level 1 neighbors. Okay, so let's get cracking onto PE1 and have a look. All right, let's get out of here and let's do our root policy. And I'm going to just call it ISIS because I'm lazy. And I'm just going to give it a pass statement and end policy. Okay, so that's just a basic policy. So the policy name, just a pass. You can go a little bit more in depth, of course, if you wanted to. If you wanted to set your weights, if you wanted to set any other preferences, if you wanted to exclude particular routes, if you wanted to do that, if you wanted to say, well, we only want the loop back of, say, CE4 to be propagated in, then yeah, fine, we can do that. But all we want to do at the moment, the basic task, is get the routes into CE2, CE1, CE4, and so they can ping each other. That's all we need to do here. So we've done our route policy. Let's go into our ISIS process, ISIS1, and let's go to address family IPv4 unicast. And if we do a question mark, we'll see the propagate further down. There we go. There's our propagate statement. Now again, on iOS XE, that you'd be using redistribution. So let's do propagate, and you tell us where we want it, what level it is. So we're going to propagate level 2 into level 1. Now the thing is, if you do this, you can actually press enter on this and it will accept it, but it doesn't actually do anything. But which is strange. But then it does tell you that you need to put your route policy in there. So route policy ISIS. Okay, so we're telling it to take all the routes that it's learning from level 2, push them into level 1, and use the route policy ISIS for that. Let's commit. All right, proof is in the pudding. Let's have a look on CE1. Enable, show IP route, ISIS. There you go. We are now receiving all the routes. You can see here the IAs. Now the IAs are ISIS external or inter-area routes. So that's good. So we've received all those, and we see that we've got the IP address 4444, which is on CE4. Now we still won't be able to ping it because CE4 won't have had that. But let's have a look here. Ping 4.4.4.4, source loopback 0. So while we have the routes, they've been pushed into us. CE4 doesn't have them because it requires PE4 to also propagate its level 2 routes. Let's have a look at CE2, which is on the far left of our topology. Show IP route, ISIS. And as we can see, we've got the routes as well. Reason being is because they've now been taken and pushed into the level 1 database on CE1, and because this is a link state protocol, the databases between CE1 CE2 have to be the same. So there we go, fantastic. Let's jump on to PE4 and let's log into this. All right, and let's go conf t, and let's do our route policy hyphen. Again, ISIS because I'm lazy, pass because I'm lazy again, end policy, router ISIS. Oops, I didn't mean to do that. No, I'm gonna have to do that again. Silly me. I got a bit too carried away with my exit, so I wasn't paying attention. Okay, route policy ISIS, pass, end policy. Okay, and let's do router ISIS1, address family IPv4 unicast, and let's propagate level 2 into level 1, and route policy is ISIS. Okay, let's commit. Fantabulous. Let's have a look on here. Let's do a show IP route ISIS. There we go. We've got all of the routes. Brilliant. Let's see if we can ping. So ping, let's do 1.1.1.1 source loopback 0. There we go. Great. Let's go on to CE2 and ping 4.4.4.4 LO0. Oh, source LO0. Yep, Brilliant. Okay, so we've successfully managed now to do task 1. So we've got full connectivity. So again, now the next task that we have to do, I'm wary that the video's going a bit far, but anyway, a bit long, is we need to apply authentication between routers CE1 and CE2. Okay, so a couple of quick questions here. Basically, what types of packets can be authenticated with on ISIS? You've basically got 2 different types of authentication. You have hello packets authentication and SP update authentication. Basically, what sort of authentication methods are used? Well, at the moment we only have plain text and MD5. And last question here, what type of authentication affects all adjacencies, and can this cause a possible problem? Yes, it can. So if you just want to do hello messages, you just want to authenticate your hello messages, so for argument's sake we want to authenticate the hellos going between CE2 and CE1, then we would put that authentication on the actual interface only, and it's only going to be interface to interface only, and it will only authenticate the hello messages. The partial sequence updates and the complete sequence updates, they won't be touched. If you want to do the actual updates, so you want them to be authenticated, then you need to do that under the actual routing, the router ISIS itself. But the problem with that is that will affect every adjacency that we have. So if I'm saying on CE1, if we decided we wanted to authenticate just the actual updates itself, then we would go into router ISIS1, we'd go into the address family, we'd go to authentication mode, MD5, authentication key, whatever our key is, and we create our key. But the moment we commit that, or we put that on there, then that's going to then drop the neighborship between CE2 and PE1. They won't be able to come up without them themselves having the actual updates authentication enabled on theirs. But then you have a knock-on effect. So if PE1 puts on the authentication for the updates, then that means that it won't be able to provide or receive any updates from PE22. So 22 is going to have to put it on, and 23, even though they're in different areas, but they're all in the same like domain, it will affect all the neighborships. So the only way we can complete this task is to just do the hello messages between the 2 devices. All right, so let's get cracking and get that done. I'm mindful that everyone probably wants to go have their dinner or something, because this video is going a little longer than I expected. All right, so first thing we need to do is to create our keychain. Actually, it's in configuration mode. And let's do keychain, and we call it ISIS. Again, lazy. Key 1 and key string, key string, and we just call it ABC123 because I'm original. Okay, so now, as we've already said, to do this we need to do it on the actual interface itself, and the interface is Gig Ethernet 2, so interface G2. Okay, and we're going to do ISIS authentication mode, and if you look, we only have MD5 and text, so it's going to be MD5, and we're going to do ISIS authentication, and now we're going to do the keychain, and it's ISIS. Okay, so there we go. So our hello messages are now securely authenticated. Let me just double check that it was actually on. Oh yeah, here we go. We can see it now. We have authentication failure for the ISIS hello. So that's fine. So let's jump on to CE1 and go into conft, and let's do keychain, and we're going to call it again ISIS. Yeah, we know the neighbors down. That's fine. And we're going to do key 1, and we're going to do key string ABC123. The key name and the key number doesn't have to match. I mean, you can use whatever you want, but the string has to match. And if you're using things like timed strings, timed keys, then you need to ensure that whichever key is active at the same time has the same string in it. Okay, so we've got our key there, we've got our string, so that's fine. And let's go exit out of that again. Let's go into interface G2, and let's do ISIS authentication mode MD5 and ISIS authentication keychain ISIS. Before we quickly do that, let's have a look here. Show ISIS neighbor. So we have no neighbors. Okay, in which case we'll have no roots either. Show IP root ISIS. Okay, so we have no roots. Let's get our adjacency come back up, and there we go, just as I was speaking. So adjacency's up. Let's have a look at our neighbors up. Let's have a look at our roots. There we go, our roots are back, and we're completely secured now. So there you go, nice, quick and easy. That was task 2 complete. So as always, the configuration files for the lab and the workbook itself will be on my website, richardclean.co.uk, and I'll have a link to that in the YouTube video description as well. Okay, well, thank you very much for watching, and I look forward to seeing you in the next one when we'll be having a go on IPv6.